It continues
This is a very strong
to rattle
earthquake.
pretty strong here.
8:21 here on the air. We're experiencing very strong shaking.
Wow.
I think we need to get under the desk.
All right, we're going to go to break. We'll be right back after
We'll be right
this.
back.
Wow.
California's coastline trembles, Oregon's volcanoes rumble, and Washington's mountain ranges quake. But this is only the beginning. While cities like Los Angeles and San Francisco experience subtle tremors, further north, unexpected shaking is recorded near the dense forests of Oregon and the snow-capped peaks of Mount Rainier in Washington state. At the same time, the ground is shifting beneath the Nevada deserts and the frozen expanses of Alaska. On that very morning, seismic activity is reported in an astonishing 9 different states along the West Coast and beyond. These widespread tremors send waves of concern through regions both familiar and unexpected. Are these isolated incidents, or are they interconnected signs of a larger, hidden force at play? The infamous San Andreas Fault in California remains a constant source of tension, but there are other potential threats. The sleeping giants of the Cascade Range, volcanoes like Mount St. Helens, Mount Hood, and Mount Rainier sit poised for activity. Could these recent quakes be signs of mounting pressure along these critical fault lines and volcanic systems? Is the Earth's crust preparing for a significant shift from San Diego to Seattle, from Nevada's arid plains to Alaska's icy wilderness? These tremors appear to be pieces of a larger geological puzzle. The interconnected nature of the Pacific Plate and neighboring fault systems suggests that these events may be part of a greater story unfolding beneath our feet. What do these disturbances mean for the future? One thing is certain: the West Coast is alive, restless, and constantly in motion, and being prepared is our best defense against what lies ahead. In today's video, we're going to break down these events, exploring the why and how behind them. We'll take a journey through fault lines, volcanic regions, and tectonic forces shaping our world. From the powerful San Andreas Fault in California to the subduction zones of Alaska, we'll unravel the patterns and possibilities lurking under the surface. Stay tuned, because what we uncover might change how you think about the ground beneath your feet forever. The Trembling California Coastline. California's coastline is one of the most seismically active regions on the planet. This dynamic landscape is home to the infamous San Andreas Fault, a massive, volatile boundary between the Pacific Plate and the North American Plate. Known as a ticking time bomb, the San Andreas Fault is capable of producing earthquakes with magnitudes of 8.0 or larger, events that could have devastating consequences for millions of residents and critical infrastructure across the state. Recent seismic activity along this fault line serves as a reminder of the immense tectonic pressures constantly building up beneath the surface. Imagine waking up in Southern California to a 2.7 magnitude quake near the Pinnacles National Park. The shaking might seem minor, almost like a distant rumble, but it signifies powerful forces at work. Just a few hours later, another earthquake strikes near the US-Mexico border, prompting further questions. These tremors are not random or isolated incidents. Rather, they resemble pieces of a complex puzzle coming together, hinting at the larger patterns of seismic activity along this fault system. But what makes the San Andreas Fault so notorious? This fault represents a transform boundary where two colossal tectonic plates, the Pacific Plate and the North American Plate, grind past each other horizontally. Unlike smooth, continuous motion, this process is irregular and jagged, more akin to a rusty door hinge resisting movement until the built-up tension reaches a critical point. When this tension is finally released, the resulting quake can be catastrophic, shaking cities, toppling buildings, and rupturing the very ground beneath our feet. The fear of the big one, a long-predicted megaquake, looms large in the collective consciousness of California. Geological studies suggest that sections of the San Andreas Fault are overdue for a significant rupture, particularly the segment that runs through Southern California. Historical patterns, such as the destructive 1906 San Francisco earthquake, magnitude 7.9, and the 1857 Fort Tejon earthquake, magnitude 7.9, illustrate the potential for violent and far-reaching impacts. While scientists cannot predict exactly when or where the next major quake will strike, the signs of increasing tension are difficult to ignore. Seismometers, ground-penetrating radar, and GPS technology all reveal the slow, relentless accumulation of stress along the fault. Efforts to prepare for this inevitability, such as reinforcing buildings, updating emergency response plans, and educating the public, are critical to minimizing potential devastation. These recent tremors, though seemingly minor, are more than mere geological quirks. They are indicators of a system under strain. Californians live with the knowledge that beneath the picturesque landscapes, the Earth is alive and restless. The question is not if the big one will happen, but when, and how prepared we will be when it does. What are your thoughts? Do these recent quakes serve as warnings that the inevitable is approaching? The Earth continues its movements, and in California, vigilance and preparedness are the keys to resilience. Nevada's desert rumblings. In Nevada, the landscape is deceptively quiet. Miles of open desert stretch out under a seemingly endless pale blue sky, with rocky outcroppings and isolated mountain ranges dotting the arid terrain. The air is still, and a sense of vast emptiness pervades. But beneath this serene surface, powerful seismic forces are alive and restless, shaping the land in ways that are both ancient and ongoing. Just days ago, Nevada was shaken by a significant earthquake measuring 5.8 on the Richter scale. This event, while not catastrophic, served as a potent reminder of the dynamic and unpredictable nature of the Earth's crust in this region. Since the initial quake, a series of aftershocks has continued to ripple through the area. These aftershocks have ranged in magnitude from 1.0 to 2.0, each one like a subtle echo of the primary quake. So far, more than 260 aftershocks have been recorded by seismologists, each contributing to an evolving understanding of the region's seismic behavior. The root cause of Nevada's frequent seismic activity lies in the geological processes of the Basin and Range Province. This vast region, which stretches across Nevada and into neighboring states, is characterized by the continuous stretching and thinning of the Earth's crust. Imagine pulling apart a piece of taffy. As the tension increases, the material eventually tears apart. In the case of the Basin and Range Province, these tears in the crust manifest as fault lines, cracks that can slip and shift, leading to earthquakes. These fault lines are complex, with some being ancient and others still evolving. When the pressure along these faults becomes too great, it is released suddenly in the form of an earthquake. This recent 5.8 magnitude quake is a clear example of such a release of pent-up energy. However, the aftershocks that follow are not mere anomalies. They are part of the fault's adjustment process as the surrounding rock stabilizes after the initial rupture. The big question on many minds is whether these aftershocks might be harbingers of a larger, more destructive earthquake. Seismologists know that the release of stress in one part of a fault system can increase pressure in nearby areas, creating a domino effect that could potentially trigger another major event. In this sense, Nevada's seemingly empty desert may be silently accumulating the strain for the next significant quake. Historically, Nevada is one of the most seismically active states in the U.S., second only to California. The region's history of major quakes, such as the 1915 Pleasant Valley earthquake, magnitude 7.1, and the 1954 Dixie Valley Fairview peak sequence, two back-to-back earthquakes of magnitude 7.1 and 6.8, serve as stark reminders of the seismic potential hidden beneath the surface. These historical events reshaped the land, creating scarps and altering the topography in ways that are still visible today. While scientists are unable to predict exactly when or where the next large earthquake will strike, they can monitor patterns and probabilities. Modern seismic technology, including an extensive network of seismometers helps track even the smallest tremors. These instruments provide data that helps researchers understand the behavior of the fault systems, improving preparedness and risk assessments. The question of whether the recent activity signals a future major event remains unanswered, buried under layers of rock, shifting fault lines, and scientific uncertainty. For now, the stillness of Nevada's desert is deceptive. Beneath the surface, the Earth is in constant motion, and this quiet landscape may yet bear witness to the next significant seismic event. For those who call this region home, staying aware, prepared, and vigilant remains essential. Alaska's Icy Quakes. Alaska is no stranger to seismic activity. With its majestic mountain ranges, expansive icy tundra, and rugged coastline, the state is positioned on the Pacific Ring of Fire, a volatile region known for its frequent earthquakes and volcanic eruption. This geological setting is a result of the Pacific Plate continuously colliding with and sliding beneath the North American plate. The friction and pressure generated by these massive tectonic forces make Alaska one of the most seismically active regions in the world. Recently, a 4.0 magnitude earthquake struck near Old Harbor, south of Kodiak Island. Although relatively moderate in scale, this quake was part of a broader seismic sequence that included smaller quakes measuring 2.7 and 2.5 in magnitude. These tremors serve as reminders that the Earth's crust is under constant strain in this region. The primary cause of such activity is the Aleutian Trench, a deep submarine trench where the Pacific Plate subducts beneath the North American plate. As the Pacific Plate sinks, immense pressure builds up. When this pressure is suddenly released, it results in seismic shaking. While these recent quakes were not destructive, they are significant because they may signal the potential for more substantial seismic events in the future. Alaska's history underscores this possibility. On March 27, 1964, the state was struck by a catastrophic 9.2 magnitude earthquake, the second largest ever recorded globally. The Great Alaska Earthquake caused widespread destruction, triggering tsunamis, landslides, and extensive ground fissures. Entire communities were displaced, and the landscape was dramatically reshaped in a matter of minutes. The question remains, could these smaller quakes be precursors to another major seismic event? While seismologists cannot predict earthquakes with complete certainty, patterns of heightened seismic activity often indicate that tectonic forces are far from stable. Monitoring systems and advanced research continue to track these patterns closely, but the potential for another significant quake is always present. For residents of Alaska, preparedness is essential, as the state's geological forces remain dynamic and unpredictable. The chain reaction of tectonic forces. Earthquakes rarely occur in isolation. The Earth's surface is composed of massive, rigid sections called tectonic plates, which are constantly shifting and interacting. These plates fit together like puzzle pieces, and their movements are driven by forces deep within the Earth's mantle. When one plate shifts or experiences a sudden release of stress, the effects ripple outward, influencing the surrounding plates. This interconnected nature of tectonic activity helps explain why an earthquake in one region, such as California, can be linked to seismic events thousands of miles away in places like Alaska or the Pacific Islands. Recent earthquakes in the Pacific region, including tremors in Alaska, along California's fault lines, and even near the distant Tonga Trench, may be manifestations of a larger tectonic adjustment occurring within the Pacific Plate. This plate, one of the largest on Earth, stretches across vast oceanic regions and is constantly interacting with neighboring plates. When stress is released in one area of the plate, it can transfer that pressure to another region, sometimes triggering additional quakes. This phenomenon is known as stress transfer and highlights the dynamic nature of the Earth's crust. An analogy for this process is squeezing a partially inflated balloon. When you press one side, the air inside pushes outward, causing another section of the balloon to bulge. In the Earth's crust, pressure buildup in one region may force another segment of the plate to accommodate the stress, potentially resulting in seismic activity. This chain reaction means that seemingly isolated earthquakes may, in fact, be part of a broader, interconnected process of global tectonic adjustment. Seismologists closely monitor these patterns to understand how stress is redistributed across different fault line and subduction zone. Although predicting specific earthquakes remains beyond our capabilities, recognizing the interconnected nature of tectonic activity helps scientists better assess potential risks. The more we understand these relationships, the better we can prepare for future seismic events and mitigate their impacts on vulnerable regions. Hidden volcanoes and the threat of eruptions. While earthquakes tend to capture immediate public attention due to their sudden and often destructive nature, they also hint at another looming geological threat: volcanic activity. Many regions prone to seismic events are located near active or dormant volcanoes, which possess the potential for catastrophic eruptions. This relationship is not coincidental. Both earthquakes and volcanic eruptions are driven by the same underlying process: the dynamic and often restless movement of Earth's tectonic plates. In Alaska, a prime example is Mount Spur, a stratovolcano located about 80 miles west of Anchorage. Recently, this volcano has exhibited signs of unrest, with clusters of small, shallow earthquakes occurring beneath its summit. These tremors suggest that magma is on the move beneath the surface, potentially rising toward the Earth's crust. If Mount Spur were to erupt, the consequences could be far-reaching. The eruption could release massive plumes of ash into the atmosphere, disrupting air travel over the North Pacific, affecting transcontinental flight routes, and coating nearby cities with layers of volcanic ash. The fallout from such an event could also impact global weather patterns, as ash and sulfur dioxide particles reflect sunlight, potentially leading to temporary cooling of the planet's surface. Similarly, in California, the Long Valley caldera presents another area of concern. This enormous volcanic depression, which measures about 20 miles long and 11 miles wide, was formed during a massive eruption approximately 760,000 years ago. Recent seismic activity, including swarms of minor tremors, has raised questions about the caldera's current state. These small earthquakes may be signals of magma movement or shifts in the underlying fault system. While no eruption is imminent, these subtle signs cannot be ignored, as the caldera has the capacity to produce explosive eruptions with widespread consequences. The link between earthquakes and volcanic activity is clear. Both phenomena are driven by the movement and interaction of the Earth's tectonic plates. When plates shift, they can create fractures in the Earth's crust, allowing magma to ascend to the surface. Stress from tectonic activity can also fracture rock layers beneath volcanoes, further facilitating magma flow. This interconnectedness means that seismic events can serve as early warnings for potential volcanic eruptions, prompting scientists to monitor these regions closely. Understanding these connections is critical for preparedness. By tracking seismic patterns and volcanic indicators, scientists can provide more accurate forecasts, giving communities valuable time to respond and mitigate potential disasters. In seismically active regions like Alaska and California, awareness and preparedness are key defenses against the dual threats of earthquakes and volcanic eruptions. What does it all mean for the future? These recent seismic events serve as stark reminders of the dynamic and ever-evolving nature of our planet. From the rugged coastline of California to the arid deserts of Nevada and the vast icy expanses of Alaska, the ground beneath our feet is in a state of constant motion. Tectonic forces operating deep within the Earth are continually reshaping the landscape, often in ways that are sudden and unpredictable. The persistent shifting of these plates underlies not only earthquakes, but also the formation of mountains, valleys, and even volcanic activity. The crucial question we must ask ourselves is this: are we truly prepared for what's coming? In a world where seismic and volcanic hazards are part of the natural order, understanding these patterns is vital for safeguarding communities and infrastructure. While earthquakes may seem like isolated random events, they are in fact part of a broader narrative, one that reflects the ceaseless energy and strain within the Earth's crust. This ongoing story is being written beneath our feet, in fault lines, subduction zones, and volcanic systems across the globe. The interconnectedness of these geological processes means that today's minor tremors could be tomorrow's major disaster. Historical records remind us of this reality. The devastating earthquakes and volcanic eruptions of the past often came with subtle precursors, swarms of small quakes, ground deformation, or increased gas emissions. For instance, the buildup to the catastrophic 1980 eruption of Mount St. Helens in Washington state was preceded by a series of small earthquakes and steam explosions. Similarly, the colossal 1964 Great Alaska Earthquake was part of the ongoing subduction activity along the Aleutian Trench. With this in mind, we must consider the possibility that these recent seismic events could be early warning signs of something larger on the horizon. Could they be foreshadowing a major earthquake or even a volcanic eruption? Regions like California's San Andreas Fault, Alaska's Aleutian Arc, and Nevada's complex fault systems are all under constant tectonic pressure. Additionally, volcanic hotspots such as Mount Spur in Alaska or the Long Valley Caldera in California remind us that magma is often on the move beneath the surface, potentially waiting for the right conditions to erupt. While the precise timing and magnitude of future seismic or volcanic events cannot be predicted with certainty, one thing remains clear: preparedness and vigilance are essential. Continued research, advanced monitoring technology, and public education are our best tools for minimizing risk and ensuring safety. Understanding the story beneath our feet empowers us to make informed decisions, protecting lives and livelihoods in an ever-changing world. What are your thoughts? Do you believe these recent quakes are harbingers of a larger event? Could we be on the verge of a significant volcanic eruption? Only time and continued scientific inquiry will tell. Leave a comment below and let us know which discovery amazed you the most. Do you think there are more hidden dangers beneath the surface waiting to be uncovered? We'd love to hear your thoughts and theories. Don't forget to like, share, and subscribe to stay updated on more incredible discoveries and hidden wonders from around the world. Hit the bell icon so you won't miss our next adventure. Until next time, stay safe, stay informed, and always be prepared. Thanks for watching.